Okay, we are going to look at naming ions and naming monoatomic and polyatomic ions, and those are the ions that end up making ionic compounds. So the first thing that you need to remember is that if you have a monoatomic ion, that means it has only one atom, okay? And that atom is either positive or negative charge, and that's from the loss or gain of valence electrons. We've talked about that several times now. That should be familiar to you. When you name a cation, it's the name of the element. And that too was something that we reviewed a little bit when we were talking about ions in the beginning of chapter 7. So when 1A, 2A, and 3A, okay, when the metals in those three groups lose electrons, they form cations. And their charge will be equal to their group number. So if we look at this right here, the periodic table, this is family 1, this is family 2, okay? And when I say 2, I mean 2A, and then family 3A. Okay, we know that the family number corresponds to the number of valence electrons. So there's 1 here, 2 here, and 3 here, right? And because it is easier to lose 1 than to gain 7, the charge here is +1, charge here +2, and charge here +3. So the elements in these families will lose electrons when they become ions, and that makes them positive. So all you do is name them. So in cations, you just use the actual name of the element. So this is the sodium ion, and this is calcium ion, aluminum. I'm writing really messy, sorry. Barium, magnesium, and rubidium. Okay, and if you were to go through on the periodic table and you would see, barium is in family 2. Sure enough, there it is. Okay. Now, with anions, the ending will be changed to IDE. Okay, so what will happen is instead of losing electrons, the elements will gain electrons, and that makes them negatively charged, and thus an anion. So what is done is you subtract 8 from the group number. So group number 5 minus 8 is a -3, and that's what charge it has. So if we look at these, this is family number 5, this is family 6, this is family 7. Now those are really the only ones we will refer to most of the time when we're talking about forming of anions, because in family 4, there's often sharing that occurs, which is covalent bonding. And in family 8, those are the noble gases, and so they already have 8. So the way that we name these, and this is one of the harder ones personally, I think, is instead of nitrogen ion, this is the nitride ion. Instead of the iodine ion, it's iodide ion. Chloride, oxide, sulfide, and phosphide. Okay, so instead of phosphorus, it's phosphide. And sometimes people have trouble with this one, and this one. So that's why those are here as examples. Now, here comes the gold sheets. The charges of many transition metals, and again, they're metals, and so they will be cations, okay, because they're positive. Sometimes they have differing numbers. Okay, so we've been focusing on, family 1, 2, 3, 4, 5, 6, 7, and 8. But there's this whole area here in the middle that are the transition metals, and that's what we are referring to. So they're not always one specific charge, they can be different charges. And in order to determine that, we look at our gold sheet. Now, you will always, just like you always have a periodic table, you will have access to your gold sheet. And I made it gold by coloring it in, but this is what the gold sheet looks like. And just to give you a little tour, because it's important for you to understand where everything on this is, these are the ones, this little area right here, that is what we just talked about. You can find that from the periodic table. All right, so you don't really need to, actually you shouldn't even need to use this because you should be able to know that automatically. But if you forget, they're all right here. Then you'll notice on here we have the transition metals for number 2 and 3. And that's what we're about to talk about. And then last, for all the remaining ones over here, 4, 5, 6, 7, 8, 9, those are called polyatomic ions, and we'll talk about that in a few minutes. So there are two ways to name ions of the transition metals. There's the stock system, which is the preferred method now, and then there's the classical method, sometimes called the us-ic method. What happens is the stock system uses Roman numerals and parentheses to indicate the value of the charge. And so, for example, here on this chromium Roman numeral 2, that Roman numeral 2 indicates that it is a charge of 2 plus, because these are all metals. So they're going to have positive ions, they're cations. So if we were to look at this, and I know this is kind of probably insulting your intelligence a little bit, but iron 2 ion, chromium, oh my gosh, am I spelling chromium wrong? Chromium 2 ion, iron 3, chromium 3. Okay, so that is very simple. You name the element and you put the number charge, and it will be given to you, or you will be able to figure it out later in different ways. Now, the classical method uses, woohoo, root word with different suffixes at the end of the word. So if there are different charges, the lower of the two receives an us ending, and the higher of the two receives the ic ending. Okay, remember before we had IDE for the monoatomics? Well, here we have us and ic. So the thing about this, it tells you, it does not tell you the specific charge. Okay, you can't find out a 2 or a 3. This is just telling you that this is the lower and this is the higher. Okay, so you can see why it would be beneficial to use the stock method. So if you look at this, we've got iron 2 plus. These are our same ones. And if you go over here, iron 2 plus is the ferrous ion. Save ferrous. Just kidding. Okay, so then Cr2 plus over here is chromous. And iron 3 is ferric. And chromic. So notice it follows what we said before. The lower of the two is the us, and the higher is the ic. Now, some of the transition metals will have only one charge, and you just know it, and you don't have to memorize it because you will always have your gold sheet. But here are the special ones that they don't switch back and forth, and these are just the names. You have the silver ion, the zinc ion, the mercury 1, which is mercurous, and the mercury 2, which is mercuric. Okay, and those are just always last and the most fun. We have the polyatomic ions. And the word polyatomic, poly is many, atomic atoms. So instead of just having one element, you will have multiple elements. And the way that I often suggest that you kind of identify it is if there's more than one. I'm just going to put an arrow up. I don't know. I was going to shorthand it, but more than one capital letter. Okay? You're going to be writing formulas a lot more, and you have to remember that when you write a formula, say for barium, the second letter has to be lowercase. Okay? And some people have trouble with that, and you really need to start making sure you do that now or you will get confused. So polyatomic ions have more than one atom, and this is a really nice list because it's separated by type. So related to water, containing C, H, and O, containing chlorine, chromium ions, not the same as before, sulfur and nitrogen ions, and then miscellaneous. Usually these will end in ite or ate, but there are 3 exceptions that you'll always be able to identify or should just know that NH4 plus is the ammonium ion, OH is the hydroxide ion, and CN is cyanide. And look, you can see this is a capital N and a capital C. So that makes sense then that it has more than one capital letter. It is a polyatomic ion. Now, if it ends in ite or ate, it is referring to oxygen. So here's our gold sheet, and here are some ions. Okay, so the clue for this is that you've got the sulfur in the first one, the sulfur. And so we'll go down here where we have our sulfur ions, SO4 2 minus, SO4 2 minus. Okay, so that's sulfate. You will always be able to use your gold sheet. So you just need to learn how to read it and how to apply the information. Next one, SO3 2 minus, sulfite. Oh my gosh, I can't write. NO3 minus, okay, which is 1 minus, is nitrate. And NO2 minus is nitrite. PO4 3 minus, phosphate. And the next one is not on here, PO3 3 minus. If PO4 3 minus is phosphate, what's PO3 3 minus? Phosphite. And of course, this is the phosphite ion, this is the phosphate ion, the nitrite ion, so you can always add ion to the end. Okay, so name the following. You've got some different situations here. So first of all, these are compounds. Now, if you are looking at a compound and there's more than one capital, if there are 2 capitals, it means that there's only monoatomic ions. If you see 3 capital letters, then it is for sure a polyatomic ion. Okay, so you always have the cation first and the anion second. Same here, same here, same here. All right, so this one, K, is potassium. So the name of the compound would be potassium, and the anion is fluorine, so it's is fluoride. And then the next one is iron, and you can tell it's going to be iron oxide, but because of the fact that it is iron, you have to indicate what the charge will be. Now that's going to get a little dicey at this point because we haven't done this yet, but let me show you. Well, we haven't done it completely. This is oxygen, right? Oxygen normally has a 2- charge because it is family 6, it gains 2 electrons. Ionic compounds are neutral. So whatever charge the anion is, the cation has to be equal but opposite. So iron must have a charge of 2+. So this would be iron Roman numeral 2 oxide. See how that works. Now we'll do another one in a second. I'm going to just erase some of this because I think it's getting a little crowded. So then we have calcium. And if you look on your gold sheet, you can see this right here, 2 capitals, polyatomic ion, nitrate, calcium nitrate. Then we have the chromium and phosphate. Chromium, now phosphate has a charge of 3-. And so if there are 3 chromiums and 2 phosphates, look at it this way. So we have 3 chromium, and it has a plus charge, and we don't know what it is yet, is equal but opposite to 2 3-. Okay, so you have 3 chromium and you have 2 phosphates right here. So 2 times 3 is 6, so there's a -6 charge on the anion side, and therefore there must be a +6 on this side. So what must the charge of the chromium be? That's right, 2. So it is chromium 2 phosphate. Okay, oh, and I didn't do it, but the USIC method, you would look that up on your gold sheet. So that is how we name ions.